Okay, welcome to the replay. My name is Joe, and I want to show you a pretty cool physics demo. Hey there, Disney Nerd 555, welcome. Okay, let me turn this around and say a quick hello. All right, welcome. Hey, Alubuk. What we have here is a giant Newton's cradle. Welcome, Victorio. Just to give you a size comparison, I'm pretty excited because I just got these recently. Here is a normal size Newton's cradle. Here's the gigantic ones. Now, if you've been following these scopes, I've been scoping every day, and for the last 4 days, the topic has actually been how to make your message more memorable. 5 brain tips all teachers, speakers should know to make sure your information gets stored. I got the normal size ones. Yeah, these ones are crazy expensive. I think it was almost like $500 for these, but very, very worth it. These are super cool. So I don't have a lot of time. So anyway, the point is, wow, I am not doing a scope today about brain-based tips for speakers. I'm mad busy getting ready for the semester. If you don't know me, my name is Joe McCullough. I'm the physics program chair at Cabrillo College. And actually I have a meeting I have to give in about 10 minutes. So this is going to be a quick little demo, but this is pretty cool. So let me just show you. So if you pull one ball up and release it, you'll see you just have one ball going back and forth. Quick question for you. Hey there, Lady Dex. Hey, Cherisalid. Quick question is, what do you think is going to happen if I pull 2 balls up and release it? Anybody want to chime in with a guess before I actually do this? So I'm going to pull 2 of these up, let it go, and see what happens. Anyone want to take a guess? Going once, twice. Hey, Mortar. 2 balls go up. You are correct. 2 will move. 2 out. So let's do it. Pretty cool. Now, let me stop this. What do you think will happen if I have 4 balls? So I'm going to pull 4 balls up, release it, take a moment. What do you think? Period of the pendulum. Yes, definitely one of the things we're going to be talking about in physics. So before I do this experiment, I'm going to pull 4 of these up, let it go. What do you think is going to happen? We have a guess of 1 from H.B. Barut. Kind of counterintuitive, 1 out. So you ready? Let's give this a try. Make sure you can see it. 1 plus 4. 5 will go higher than the drop of the 4. Okay, here we go. Still have 4 balls going each time. Now I'm going to show you one other one, which is pretty cool. Last one, I'm going to try and pull 2 up on one side, 1 up on the other, and then let it go. See what you think is going to happen. So I'm going to pull 2 up, 1 up, let them go. What do you think is going to happen? Oh yeah, pulling 2 balls up and then 1. Let's give it a try. See if I can do this. Atom Smasher. Okay, why does this work? Because it is counterintuitive. For those of you just joining, what we have here is a giant version of Newton's cradle. You probably have seen these before. Here is just to give you a comparison of the size. Here's the little baby Newton's cradle. Here's the big giant Newton's cradle. And so, a few things. This works because of conservation of energy and conservation of momentum. Kind of mathematical, so I'm not going to go through it in detail, but what it says is however many balls I pull up, that's how many are going to get moved up on the other side. So if I pull 1 ball up, you've got 1 ball going on each side. If I pull 2 balls up, 2 balls going. Now 3 and 4. If I pull 3 up, still always going to have 3 on each side. has to be because of conservation of energy and momentum. And then last but not least, can you say welcome for Turkey? Welcome from, I can't see that, but welcome for Turkey. Awesome to have you join me. Now if I pull 4 up, pretty cool, huh? I still have 4 going each time. The reason that has to be is because the only way for you to conserve both energy and momentum is to have the same number of balls going each time. Haha, that's awesome. That is cool. Thank you. One more time. Another cool one is if I pull 2 up and then 1, well, 1 if I do 1 each. But one that I think is pretty cool is if you pull 2 up and 1 up at the same time and then let them both go. Okay, let me try that one more time. How many cool toys are in your office like the drinking bird? I have some awesome, awesome cool toys. In fact, I have to go in a second, but let me just quickly show you our physics stock room here at Cabrillo College. And some of the cool stuff. Let me turn this around for a second. So we have an entire stock room full of awesome physics equipment. Some of this stuff over the course of the semester. Okay, let me quickly show you this one more time and then I'm checking out. For those of you just tuning in, my name is Dr. Joe McCullough. I'm the physics program chair here at Cabrillo College, and I made a goal to get on Periscope every single day for an entire year to give you daily doses of dopamine through education, entertainment, and inspiration. I have been doing a 5-part series on the brain and what all speakers need to know in order to make sure their message is remembered, but I'm crazy busy today, so I didn't get a chance to finish it. Would it work on the small ones? Mine is in a storage to try. The answer is yes, they'll work for any Newton's Cradle. So here's the little teeny version. So if I pull 2 and 1, now the thing about these is the strings are kind of wonky, and this was kind of a cheap one. The one that I have here, this one is a serious Newton's Cradle. I think this was something like $500, but it was well worth it. So let me show you it one more time, and then I'm going to check out for today. I have a meeting I got to go to. 1 ball up, I get 1 ball going each time. If I pull 2 balls up, 2 going each time. 3 up, you're going to have 3 going each time, and 4 up, you still have 4 going each time. The reason this works has to do with conservation of energy and momentum. They both have to be conserved, and the only way for that to happen is if the same number of balls rise on each side. One last cool thing is, let's say I do, well, let's try 3 and 1. I don't know that I've done this one. So I'm going to pull 3 up and 1 up and let them go. This will be our very last demo. Before I do that, what do you think is going to happen? So I'm going to pull 3 balls up on one side, 1 ball up on the other, let them go so they hit at the same time. What do you think is going to happen? Anybody want to take a quick guess? No guesses? Okay, well, here we go. Hey there, Terry Lynn. We're about to do our last part of this demo. So in this case, I'm pulling 3 plus 1. Let's check it out. 3 on one side, 1 on the other. Physics rules. Okay, I'm going to continue with my 5-part series. Thank you for the demo and have a great afternoon. Thank you, Disney Nerd. I'm going to be continuing with more physics demos next week. It starts the semester at Cabrillo College, and what I think is next week I'm going to do a 5-part series on some awesome physics demos. If that sounds good to you, please swipe from left to right on an iPhone, straight up on an Android, and follow me or share this with people you think might enjoy it. You can also follow me on Twitter at Dr. Joe McCullough. Hey there, Mark Joseph. So again, I'm going to finish my 5-part series on the brain and brain facts that all speakers must know to make sure their message gets remembered. Probably not going to get a chance to finish that until Monday. I'm crazy busy finishing the semester, but I will still be scoping every single day. See you then. Thank you, Disney nerd. I enjoyed spending a little bit of time with you. Any last questions I can answer about this giant Newton's cradle? Key things here are conservation of energy and conservation of momentum. The only way for them both to be conserved is if I pull, let's say, 3 balls up. When they hit, 3 balls have to leave. Last time. All right, well, thank you so much for the hearts, and I hope to see you all again. And next week, I'm going to show you how you can freeze time Matrix style. It's going to be super duper cool. I hope to check you out then.